Hey Ramblers, this video covers chapter 10.9 in our textbook and deals with arc length and circumference. Now you've already been introduced to all the topics that I bring up in this video. We've already learned the formula for finding the arc length and its relationship to arc measure and its similarity to the area of a sector. So there's a lot of very related information here. So maybe it's a good idea to go through this section again, just because in my experience it's one that's it surprised me how much trouble students have had with it. But again, there's really nothing new here, and it's not even more difficult than what we've learned in the past, but there is more application. So let's go through the material pretty quickly. There's just one sketch, and then we'll have a couple of tutorials for you to help you with the exercises. Okay, Ramblers, thanks for watching, and I hope this helps. Okay, perhaps the most confusing part of this section is the difference between arc measure and arc length. So let's go through it just to differentiate it. Let's take a look at this circle O, and you'll notice that we have a radius drawn to point A, but I also have another radius drawn right on top of it to point P. And if I animate point P, I can see that it rotates around the circle, and it creates an arc. That arc has a measure that is related to the measure of the central angle. So let's take a look at some of the formulas we know. And once again, we're reminded that the arc measure is equal to the measure of the central angle. So the measure of arc PA is going to be equal to the measure of angle POA. Now we're going to get into arc length, and just to make sure we're clear on the difference, arc length is a linear distance. So it's equal to the arc measure divided by 360 times the circumference. And the purpose of this arc measure divided by 360 is to show you that this represents the fractional part of the circle that the arc is. When you multiply it times the circumference, you get the length. Okay, well let's see what happens when we add another circle. Now you can see that PA and QB are two different arcs. Yet you'll see that that their central angles, AOP and central angle QOB, have the same measure, and their arc measures are the same. And as I animate the point, no matter what I do to point P, these arcs and these angles will stay the same measure, but the lengths will not. And that should be pretty clear why. If we look at the calculation for arc length, you'll see once again that it includes the arc measure, and we've said that the arc measure of AP and the arc measure of QB are the same. It is the second part of the calculation, because as we multiply the arc measure over 360 times the radius of a big circle versus the radius of the small circle, you see that we get two very different arc lengths because the radii are very different. So as point P moves, the arc on the bigger circle will always be larger than the arc on the smaller circle, despite the fact that their arc measures are the same. We'll get a different arc length. Okay, Ramblers, that's really the gist of this section. I will include a couple tutorials here, and I hope this helps you make it through the exercises. Thanks for watching. Okay, Ramblers, so in this video we looked at arc length and arc measure, and hopefully you saw the difference between the two. Arc measure is the measure of an arc out of 360, and arc length is a linear distance along the circumference of the circle. So arc length will always be the arc measure over 360 times the circumference, and arc measure is just the measure of the arc, which of course will be equal to the measure of the central angle. Okay, Ramblers, please stay tuned for the tutorials. Thanks for watching, and I hope this helped. Number 5 asks us to find the perimeter of the figures that are drawn. And so the trick is going to be to add up these straight pieces along with the curved parts. And so in letter A, I'm going to add up these 4 straight pieces here, and by the tick marks I can assume that all 4 of those are congruent, So that's going to be 4 times 10 plus we're going to have 4 of these arcs, and of course the arcs are going to measure by the tick mark there. I can see that it's 90 over 360 times the circumference, and since this 3 tells me that the radius of each of these is 3, I'm going to say it's 2 pi times 3. So the answer for A is going to be 40 plus the 4 and the 360 will reduce, and so I'll just be left with 6 pi. Okay, let's take a look at B then. So that's A. Let's take a look at B. We have 3 sides that are all 8, so that's 3 times 8, plus now we have to find this curved portion, which of course is a half a circle that has a diameter of 8. So that's going to be 180 over 360 times 8 pi. And when you simplify that, you get B is equal to 24 plus 4 pi. Okay, C is going to be this ice cream cone shape, which has 2 sides that are 6 and 6. So that's easy enough. And then another half circle with a diameter of 12. So that's going to be plus 180 over 360 times 6 pi, which gives us a final answer of 12 plus 3 pi. And then the last one, D, see if we can fit it on here, is going to be these 2 straight portions, 3 and 3. So that's going to be 6, plus 2 semicircles. The first is going to have a radius of, or I'm going to say a diameter of 4, and the second one's going to have a diameter of 4 plus 3, or 10. So we'll have 6 plus 180 over 360 times 4 pi plus 180 over 360 times 10 pi. And that's going to give us our final answer of 6 plus 2 pi and 5 pi makes 7 pi. Sorry to squeeze it in there. Thanks for watching, Ramblers. Okay, number 9 gives trouble every year, and it's mostly 9A. So let's go through it. In this picture, we know that AO is a radius of this arc AB, and we're trying to find the length of AB. So the trick is going to be recognizing that this is an equilateral triangle. So this perpendicular drawn from B through O, perpendicular to the other side, that's going to bisect this side. And I also know that this AO is going to bisect this vertex angle, giving me a 30, 60, 90, whose one side opposite the 60 degree angle is 9. So that makes the side opposite the 30 3 root 3, so the hypotenuse will be 6 root 3. I'm going to import that 6 root 3 into my arc length calculation, and now all I need is the measure of this angle, theta we'll call it. And since I know that in this 60, 30, 90 triangle this was 60, theta has to equal 120. So when I calculate all this, I'll get 1/3 of 12 root 3 pi, or 4 pi times the square root of 3. I'll leave B and C to you because these are good practice problems, and but I think A is the hardest one. Okay, thanks for watching.